So, quickly moving through solving basic equations, we previously we did a problem on equalities, and now I'd like to speak a little bit about inequalities. This is another topic that I'm sure you have seen in the past, an inequality. And an inequality can be written with several different signs, inequality signs. One of those is a less than sign, another is a greater than sign, the other is a less than or equal to sign, and another is a greater than or equal to sign. So these are all options for inequality signs. Now, there are some properties of inequalities for solving inequalities for a variable at least that are a little bit different than solving equalities. Let's look at a problem. Let me just grab a different color. Alright, so let's look at -3 times the quantity 2x minus 5 plus 1 is greater than or equal to 4. Alright, fairly similar to an equality, we have some distribution that we need to work with here. We have the -3 to distribute to these two terms. So let's do that now. So if we multiply the -3 times the 2x, that leaves us with a -6x. And if we multiply the -3 times the -5, we're left with a positive 15. Then we tack on the plus 1, drop down the greater than or equals to sign, and then drop down the 4. Alright, so now we have a couple of like terms we can combine here. This 15 and this 1, and also this 4 are actually all like terms. So let's combine the 15 and the 1. Leaves us with -6x plus 16 is greater than or equal to 4. And then just like we're solving an equality or an equation for a single variable x, we can subtract this 16 from both sides. So if we do that, that cancels the -16 and the positive 16 here. We're left with -6x is greater than or equal to, and that leaves us with -12. All right. So our last step, we want to isolate x completely. Now the only way that we can do that is to get rid of this -6 here. Well, that's multiplication going on between the -6 and the x, so let's do the opposite and divide by -6 on both sides of the inequality. And if we do that, the -6 cancels with the -6 here, that just becomes 1, and we're left with x. And then on this side, we get -12 divided by -6, and that becomes 2. Now, since we divided by a negative number, that means we need to flip or reverse the inequality sign that we're using. So this greater than or equals to sign actually becomes a less than or equals to sign. So now we are actually left with a statement that says x is less than or equal to 2. And now we can actually graph this on a number line. So if I have my number line here, I feel like I could possibly make that a little bit better. Okay. And let's mark some pieces on here. Let's put the 0 here. And then we're going to put the tick marks here. And we can put 1 2, 3. And this goes on for infinity in both directions. And then we can make some tick marks on this side. -1, -2, -3. All right. So now if we're graphing this x is less than or equal to 2, well, since it's less than or equal to, then that means that x could be the integer 2. So what we're going to do is we're actually going to make a filled in dot here on the 2. And then we are going to fill in everything below that 2. So that actually indicates, since we have a filled in dot here, that indicates that this inequality can actually equal 2. If this was an open dot, if there was not filled in, then in that case, this would have to be either a less than sign or a greater than sign, not or equal to. So that is an example of an inequality where you have to reverse the inequality sign. Next, we're going to talk about inequalities and whether they're always, sometimes, or never true.